Our seventh lecture video on properties of matter will cover properties of liquids. Even though cohesion and adhesion are properties of solids, they are also properties of liquids. Cohesion is the force of attraction between like molecules in liquids. As an example, cohesion is what causes molasses or syrup to be sticky and to stick to other molecules of molasses or syrup. Adhesion is the force of attraction between unlike molecules. Even though your finger is technically a solid, the syrup is still a liquid, and adhesion is the force of attraction between the syrup sticking to your finger. It is important to note that a liquid whose adhesive forces are greater than their cohesive forces will wet any surface it comes into contact with. On the other hand, a liquid whose cohesive forces are greater than their adhesive forces will leave objects dry. The third property of liquids is surface tension. Surface tension is the ability of a surface of a liquid to act like a thin, flexible film. At the liquid-air interface, surface tension results from a greater attraction of liquid molecules to each other through cohesion than to the molecules in the air, which would be adhesion. The net effect is an inward force at its surface that causes liquids to behave as if its surface were covered with a stretched elastic membrane. In this manner, we can see that water droplets stays as drops because the surface tension is so strong. In our other picture, we have a water strider. A water strider is able to seemingly walk on water because its weight is distributed evenly across its 6 hydrophobic or water-resisting legs, even though they are technically more dense than the water. The fourth property of liquids is viscosity. Viscosity is the internal friction of a fluid that is caused by molecular attraction. Viscosity can also be thought of as resisting a tendency to flow. If we think about two common liquids, water and oil, water is more dense and less viscous as compared to oil, which is less dense and more viscous. When we say water is less viscous, that means it flows easier than something that is more viscous. Another thing that many of you have probably observed before is if the temperature is increased, the viscosity decreases, meaning the liquid flows easier. This is why if you are changing the oil on a vehicle, you typically want to do it on a hot engine. The oil will have a higher temperature and be less viscous, meaning it will drain faster. The fifth and final property of liquids we are going to discuss is capillary action. Capillary action is the behavior of liquids that causes the liquid level in very small diameter tubes to be different than larger diameter tubes. Capillary action is due to both the adhesion of the liquid molecules with the tube and surface tension of the liquid. In water, for example, the adhesion between the water and the glass tube is greater than cohesion between the water molecules, so water creeps up the sides of the tube. In this picture, we have water in the two tubes on the left side and mercury in the two tubes on the right side. With water, the more narrow tube has the water rise higher because, again, the adhesion between the water and the sides of the tube is greatest, so the water is seemingly sucked up the tube. In mercury, the cohesive forces are greater than adhesive forces between the mercury and the glass tube, so in the more narrow tube, the mercury level is much lower than in the wider tube. If you look closely at the meniscus, or the crescent-shaped surface of the liquid, we can see that with water, it is concave, meaning it rises up along the sides of the container. With mercury, it is convex, or falls down along the sides of the container. Capillary action is also how trees and other plants get water from their roots in the ground to their branches and leaves much higher up. This concludes our discussion on properties of liquids.